Okay, so members, now let us see what happens when they give you one trig ratio and then they ask you to get others. This is what happens. Please don't forget to subscribe to the channel. Okay, start with, if they give you anything that deals with trig ratios, we have to use a right angled triangle. Now we see, in this example, they're telling us that given that tan is defined, if A is acute, A is acute, we say A is acute because if it's between 0 and 90. If A is acute, find cos A, sin A, and then this one. It means we have to first use the right angled triangle. So immediately they give you this, you come and draw a right angled triangle because all trig ratios are defined using a right angled triangle. Now it's that they are giving me A. So they are giving me angle A, like this. So now look at if it's dealing with, if we are dealing with tan, it means that we are using socator. Let us first note here our socator. If we are given tan, it means that they are giving us the opposite and then the adjacent. So this is going to be our opposite, and this one is going to be our adjacent. That's what we do first. This is going to be our adjacent. So now we put on this triangle here. So our opposite to this angle is 3. Then the adjacent is 4. Now they're asking me to get cos, but to get cos, you see that in cos, I need to get the hypotenuse. How do you get the hypotenuse? From here, we just use our Pythogoras theorem. That, from here, we just say hypotenuse squared will be equal to adjacent squared, then plus the opposite squared. This will be our adjacent 4 squared plus 3 squared. So my hypotenuse will be the square root of, this is 16, plus 9, which is 25, and 6 will be 5. So this one is going to be 5. Now, if I have the hypotenuse, now I can get other trig ratios. How? My cos A, remind me what? My cos A. My cos A, we say, is given by adjacent over hypotenuse. Adjacent over the hypotenuse. Now we're done. When I come now to my sin A, if I want sin A, my sin A, we said, is given by opposite over hypotenuse. My opposite, this angle is 3. The hypotenuse is 5. And you are through, just like that. Then you want sin squared, and then cos squared, as I remember 3. This is the same as, we are going to get the sine, you square it. 3 over 5, then you square it. Then plus cos square, which is 4 over 5, then you square it. When you square this, you get 9 over, when you square 5, you get 25. Plus, when you square 4, you get 16. When you square 5, don't always, never forget to square the denominator also. You get 25. And you see when you sum, we have 9 plus this because we have the same LCM. 9 plus this will get 25 over 25, and this will be 1. And then for members, you see this is not a problem because that is an identity. Anyway, so that's how we handle that. We always use the right angle triangle. Let's handle this. If theta is this and theta is between 90 and 180, now what do they mean? Always be careful with the signs. So this sign, it means that we have seen that sign is positive in 2 quadrants. The first and then the second. So if it's positive, now they are giving us the specific angle that this theta is between 90 and 180. What does it mean? It means that this from 90 to 180, that is the second quadrant, meaning that this angle is going to be in the second quadrant. So it means that now all we deal with, we have to be putting some care when we are getting these two, because this one is in the second quadrant. See, from 90 to 180. So you see that this is going to be the quadrant we are going to use. Now, to get this, to get these ratios, we first use now a right angled triangle. So in my solution, this is sin theta equal to 12 over 13. Immediately I draw my right angled triangle like this. This is my angle. Now the angle I'm handling is the theta. Now this one is going to be our opposite, and this is going to be our hypotenuse. Why? Because in Sokatoa orange side is given by opposite, then over hypotenuse. So our opposite from here is 12. Then our hypotenuse is 13. So it's that we are missing this side. Using Pythogoras, you see that now adjacent we are missing it squared plus the opposite squared. We shall get the hypotenuse squared. From here, our adjacent is what we are looking for. The opposite is 12, but we are squaring it to be giving us 13 squared. So now our adjacent will be the square root of, and the square is you get 169. When you take this side, 144. 144. And so that there, our adjacent is going to be now 5 units. So meaning this is going to be my 5 there. Now from there, what happens? I have the already adjacent now. So meaning I can get cos and I can get tan theta. So from here, my cos theta, or my number 1, is going to be, it's given by adjacent over hypotenuse. So my adjacent is 5, hypotenuse is 13. I'm through with that. Then on my number 2, I want tan theta. Tan theta is given by opposite, which is 12, over adjacent, which is 5. Now, because this theta is in the second quadrant, remember in the second quadrant, this is negative, and also this is negative. In the second quadrant, it's only sign that is positive in this quadrant. That's why I'm attaching negatives there. Here we never attach any negative because if A is acute, it means it's in the first quadrant here. So in the first quadrant, all of them are positive. That's why all of these were positive. But in the second quadrant, it's only sign which is positive. So these two are negative in that quadrant. That's the idea I'm using there. Then number 3, always be careful with the angle they are giving you. If they specify, now in simple terms, this angle was obtuse. You see, it's from between 90 and then 180. So it was obtuse. If they don't use this, they can use the word obtuse. So now 3 sin theta plus 2 cos theta. This one we shall just substitute. 3 into our sin theta. Our sin theta is 12 over 13. Then plus 2 our cos theta, which is negative 5 over 13. When we multiply here, we have 36 over 13. Multiply here, we get negative 10 over 13. This number is only one if you have a scalar, which is not a fraction. This one multiplies the numerator only. That's why I'm multiplying this and this to get this, then this and this to get this. When you simplify there, it's that the same LCM, so we have 13. Then 36 minus 10, you get 26. And so that becomes our answer there. Here we are spreading material, we just multiply through by that. Now, this is mainly for lower level, then let us go to higher level. Now here they are bringing in some cosec and so on. Now, here they are giving us a given that cos is that and sin B is that. If A is reflex, now, if A is reflex, it means that you saw it's positive. But if it's reflex, we say reflex is from 180 to 300. But you see that I'm not going to use the third quadrant because here the sign is positive. It means that it was reflex, but specifically in the fourth quadrant. Why? Because cos is positive in the fourth quadrant. So reflex, we have 3 options. We have 2 options. If an angle is reflex, it can be here or here. But because basing on this is positive, it means cos is only positive in the fourth quadrant, meaning it's reflex but specifically in this quadrant. That's the interpretation there. And B is acute. So B is acute means that this B is lying in this quadrant. So that's what we have from the all those sine, cos, and so on, they are positive in there. So what is going to happen? So see that I need A and then I need B. So I come first of all for the A. My cos A is 3 over 5. So I draw this triangle here first of all. which enables me to get the other angle. So if this is f, cos is given by adjacent over hypotenuse. So my adjacent is 3, hypotenuse is 5. So when you use Pythagoras, when you practice this, you see we are going to be having this as our opposite. This squared will be this squared. So 5 squared, then minus 3 squared. And you see that our opposite is going to be 4. When you calculate, I think it means in the as it means for it to live. So this opposite is 4. Then I come to this. Now I have my sine b equaling to 5 over 13. Immediately I draw my triangle there, right angle triangle, what we use. So this is my b, this is my opposite, this is my hypotenuse. So my opposite is 5, hypotenuse is 13. Then when you calculate, so that now my adjacent square will be, now this is squared, then minus 5 squared. After doing this, I need to take to their side. That's what I'm doing. This will be now square root. Now my adjacent 169 minus 25, which will be 12. So this one is now 12. So after getting that, now I have all the sides. Meaning I can now get, because in tan, to get tan we have to first get the sine and then the cos of those respective angles. So that here, now I need, to get this, I need tan B, I need also tan A. So from here, my tan A is, but I have to be careful, A is reflex, but tan, here, we know now why it's specifically here. Here, it's negative, so that's why I'm talking the negative. Opposite, which is 4, over adjacent is 3. Then I'm interested in also sine A, because cosec deals with sine. So I want also sine A. My sine A. Now A is reflex, it's here. In this quadrant, sine is negative. That's why I'm having here now my sine A. Opposite, which is 4, but negative over hypotenuse, which is 5. When I come to this now, I start by getting my tan B. My tan B, my product that B is acute, so meaning that all of them are positive. Because acute, it's in the first quadrant and all of them are positive. So it's opposite, which is 5 over 12. Then sine B is already, then I get my cos B. My cos B is equal to adjacent over hypotenuse. As simple as that. Why these ones are positive? Because B is acute and acute is in the first quadrant. That's the only interpretation. Okay, now I come to problem number 1, tan A. I have tan A plus B. You know that how to expand this in a trig. This is the same as tan A minus tan B. Plus tan B over 1 minus tan A tan B. That's how we handle it in trig. Okay, now tan A is there, negative 4 over 3 plus tan B. Our tan B is 5 over 12. The whole over 1 minus now tan A, which is negative 4 over 5 times, over 3. Then times tan B. My tan B is 5 over 12. Let us simplify this and see. So the LCM is going to be 12. The LCM is 12. So 12 goes here. The LCM is 12. From here, we are going to be having 12. 12 goes, 3 goes here, 4 times. 4 times this, we have negative 16. Then negative 16 plus this, we shall end with negative 11. When you simplify the denominator, the whole over 12 goes here once. Then 1 times this, that is 5. Then 3 goes here, 4. 4 times this, negative 16. Negative 16 plus 5, that's why we have negative 11 there. Then if you multiply here down, you see you have 1 plus this negative. This is going to give us now 20. And with this, yeah, by the way, you can reduce by 4 here 1. Anyway, let us leave it the way it is. We have this and this, we have 20 over this and this 3, and this we have 36. And so we can simplify this. This would be negative 11 over 12. Now divide by, this would be 36 if you cross multiply again. 36 plus 20, 56 over 36. Which we can easily see is going to give us a reciprocal. So we shall be adding negative 11 over 12, then times 36 over 56. And from there, you can see that now my turn A plus B is giving me. From here, you see by 2 cancels, by 12 there, then 3, it will be now negative 33 over 56. Yeah, 56. And that is our answer. Then when I come this, I need cosec, but you know that, remind me to cosec A plus B, sorry, to be clear, visible enough. Know that our cosec A plus B is the same as 1 over sine A plus B. So meaning we first get sine A plus B. From here, my sine A plus B, let's give it by sine A cos B plus sine B cos A. We just substitute our sine A. Where is our sine A? From here, our sine A is negative 4 over 5. Then times our cos B. Our cos B from here is 12 over 13. Then plus our sine B, which is 5 over 13. Then times our cos A. From here, our cos A, which is 3 over 5. And there we just simplify. You see that we are going to be having 5 times 13, 65. So up you have negative 48 over 65. Then plus, you have there 15 over 65. When you simplify this, is that this, when you subtract from 15, will be having negative 33 over 65. So this is your sine A plus B. Now your cosec A plus B will be now negative the reciprocal of this. Or you said it's going to be 1 over the value of sine. 1 over the whole of this, which is negative 33 over 65. When you get the reciprocal, you get negative 65 over 33. So that's it, members. I will see you when